Okay, hi guys. Let's practice some limits. Let's talk about limits because they're going to be pretty important for our class. There's three ways you have to know a limit, and one of those ways is numerically, which is the first thing I'm going to talk about. When I say numerically, I mean can you study a limit in a table? The other two ways to study a limit is you could look at it graphically. So number two is graphically, which means can you just visually look at a limit? And then number three, this is where the work is going to come in. Number three is can you study it algebraically, or I'm going to write analytically. This is the more traditional paper and pencil solving it by hand type way. So I could ask you about pretty much any kind of limit. I can make up a problem here in a minute, and I could ask you to show me all three different methods, and you would have to know how to go about it. So let me give you an example of when you would ever need numerical limits. Example 1. Let's say I have a function and it's y equals x cubed minus 1 over x minus 1. So right away I know it's a fraction, and I'll move it up here, and I know that I can't have 0 in the denominator. So this is a totally fine graph as long as x does not equal 1, because 1 minus 1 is 0. And we call that a vertical asymptote. So vertical asymptotes are when you end up having a dotted line or a hole on the graph. Okay, so we have this vertical asymptote where there's a hole or an asymptote or something going on the graph. And we know x cannot equal 1. But who's to say x cannot equal something really close to 1? And when I mean really close, I mean like really, really close, like 0.9, 0.999, 0.9999999. That's practically 1. I mean, in our world, if you see 0.999 repeating, you just round it up to 1 anyways. But mathematically, it's not 1. It's a decimal really close, and that's what a limit is all about. So I'm going to make a little table, and it's going to be just a traditional XY table, and I'm going to pick numbers that get really, really close to 1. And I'm going to set this table up in kind of an organized fashion. And I'm going to pick those numbers I was just talking about, 0.9, 0.99, 0.999. And then I'll put 1 in the table. On the flip side of 1, what are numbers really close to 1 on the other side? Well, something small like 1.001, 1.01, 1.1. These are the numbers that I'm going to take all these numbers and plug them into here to see what's going on with the function. Now if I plug in 1, I'm going to get D&E. It's undefined. It doesn't work. But all of these other numbers should work. And this is what a good table looks like. It's got 3 values on the left, 3 values on the right. You want 3 on the left, 3 on the right to have a really good table. So most of that work is going to happen on the calculator. And let's do this thing. Let's go to my y equals here, and let's type in x to the third power, parenthesis x to the third power, minus 1, all divided by x minus 1. And I'm going to skip graphing. I don't need to look at the graph. Forget the graph. I need a table. So I'm going to go second table, and I'm going to hand enter these numbers, 0.9. I've already done this, 0.99. 0.999, 1. You can see I already did this earlier. But look at what the numbers are doing. There's an error message when you try and plug in 1. There's an error message because 1 does not exist. That makes sense. But all the other numbers worked out really good. We got some actual values on here. So let's take those values and basically copy them out of the calculator and write them down in our table. We got 2.71. 2.97, 2.997, then we got the error message, and then on the flip side of that we got 3.003, 3.0301, 3.31. So if somebody said, can you tell me what these numbers are heading towards? What are they both getting really, really close to? You would logically say 3. From both directions, it's getting really close to 3. That's what a limit is. You'd say the limit as x approaches, and x is what we focused on. We focused on the number 1. So it's the limit as x approaches 1. That's our focus. for x cubed minus 1 over x minus 1 equals 3. That's my answer. That's getting really, really close to 1, focusing on 1, getting a value of 3. So limits numerically mean build a table. In the next video, I'm going to work on graphically, and then I'll do a couple of videos on number 3 because analytically is where it gets hard. So keep watching, stay tuned for a couple more videos on this. And I guess the most important thing to note out of this video is when you organize your table that you have 3 values on the left and 3 values on the right. That makes a good table. And it goes from smallest number to biggest number. So less to greatest. Think of it that direction. And then you should be fine. You should be able to do these.